Welcome to The Explainer. Look, if you're following tech right now, you know AI is moving at light speed. And honestly, the sheer volume of developments can get tangled even for the experts. So today, we're taking a macro, micro, macro journey through artificial intelligence to map it all out cleanly and see exactly how we can optimize our everyday workflows. Here's our roadmap for today. We're going to start by demystifying the AI jargon, then look at how machines actually learn, dive into generative AI and LLMs, master some prompt engineering, and finally, look ahead to AI agents and the future. All right, part one, demystifying the AI jargon and clearing out that fog of buzzwords. We hear the term AI thrown around constantly, right? But it really helps to visualize it as this giant umbrella. It's the overarching field in computer science entirely focused on training computers to simulate human cognitive intelligence. We're basically trying to get machines to do things that we are naturally good at. And that covers the whole shebang, from basic rule-based regular expressions all the way up to incredibly complex modern robotics. Now, here is where things get really fascinating. Machine learning literally flips traditional programming completely on its head. Think about it. With traditional software, you write explicit logic, equations, rules, you feed in an input, and you get an output. But machine learning? Totally different ballgame. You feed the computer the inputs and the desired outputs, say a massive pile of spam and non-spam emails. The machine then figures out its own logic and patterns from that data. It writes the rules itself. So when we look at this breakdown, the jump from traditional AI to generative AI makes perfect sense. Traditional AI is all about analyzing, predicting, or classifying. It's looking at that labeled, supervised data to flag a spam email or guess what a house might sell for. But generative AI? It's trained on massive internet-scale datasets to create brand new content. So traditional AI analyzes the world we have, while generative AI actually creates entirely new pieces of it, whether that's drafting a poem from scratch or rendering out a marketing video. Moving on to part two, how machines actually learn. Let's zoom in to the micromechanics. Okay, so there are basically two main ways we teach these systems. First is supervised learning. This relies strictly on labeled data, those input and output pairs we just talked about. It's kind of like instructing a kid to put all the toy dolls in one specific bucket and all the toy cars in another bucket. Very explicitly guided. Unsupervised learning, though, uses unlabeled data. The AI has to autonomously find hidden patterns on its own. Imagine just letting that same kid loose in a messy toy room. They might decide to group things by color or maybe by size, noticing their own patterns without you ever telling them what to look for. And the way data flows through these networks is just as important. A feed-forward network is exactly like a juicer. You push your ingredients in one end, and the juice comes straight out the other. There are no loops. It's a one-way street. But a recurrent neural network, that's way more like cooking soup. You taste it, realize, needs more salt. You get that feedback, and you iteratively adjust the ingredients over time. It loops back on itself. Let's tie this all together with a really practical question. When you upload a photo into one of these deep learning systems, how does an AI actually recognize a koala? Well, think of the neural network like a giant classroom. You've got individual students. These are our neurons. First, they try to detect basic features. One student guesses if they see round, fluffy ears. Another is specifically looking for a prominent oval nose. Next, a manager neuron in a higher layer takes all those individual scores and combines them to see if it makes a face. Then the final guess goes to the supervisor to check against the real answer. If the network guessed lion instead of koala, well, that error feedback gets passed backward. This backward error propagation basically tells the classroom, hey, you were way off, adjust your weights and guesses for next time. This constant cycle of trial, error, and adjustment, that is the absolute heartbeat of deep learning.
All right, part three, generative AI and LLMs, the engine of creation.
You know, this stochastic parrot concept is honestly one of the best ways to wrap your head around large language models. What the model is doing is using statistical probability mixed with a little bit of randomness to predict the exact next word based entirely on past conversations. It has zero actual understanding of the meaning. These massive LLMs are incredibly advanced statistical guessers. They aren't sentient. They aren't sitting there pondering the meaning of life. They are just mathematically predicting the most logical next word based on trillions of text examples. And obviously, as we've all seen, this has exploded far beyond just text. We're looking at incredibly diverse modalities now. For text, you've got the heavy hitters: OpenAI's GPT, Google's Gemini, Anthropic's Claude, and Meta's Llama. Then you have image generators like DALL-E and Stable Diffusion, audio generators like AudioGen, and then there's video. Mind-blowing models like Sora that can take a highly complex prompt, like a translucent octopus climbing up a mountain, and instantly generate a hyper-realistic video of exactly that. It's wild.
Which leads us to part 4, mastering prompt engineering, controlling the models.
It is so easy to treat prompting like a one-and-done magic trick. You type something in, poof, you get an answer. But the real power user move is treating it as an iterative loop. First, you start with an idea and formulate your goal. Second, you write out clear instructions, your prompt. Third, you evaluate the result the AI gives you. And finally, the most crucial step, you analyze where it fell short and refine the prompt. You loop through this, tweaking and adjusting your constraints until the output is exactly what you envisioned. We can actually supercharge that loop by using what we call shots. Zero-shot prompting is basically giving the AI a task completely cold, with no prior examples. You just say, classify this feedback as positive or negative. And honestly, on modern models, that works pretty well. But few-shot prompting, that is a real game changer. That means providing a clear, written example of what a good output looks like before you ask it to do your specific task. You're giving it an exact template to mimic, which dramatically boosts its reliability. If you want to skip the guesswork entirely, you absolutely need to use structured frameworks. RTF is a classic. It stands for Role Task Format. Give it a persona, act as an expert copywriter. Give it a task, write a welcome email. And give it a format it as a bulleted list. Boom, done. For heavier, more complex jobs, step up to Ryzen. Role, instructions, steps, end goal, and narrowing. That narrowing part is key. It lets you slap on specific constraints like a strict word count or telling it to avoid certain jargon, keeping the AI perfectly on the rails.
Okay, finally, part 5, AI agents and the future. Zooming out to the macro impact. So we are rapidly moving past standard conversational chatbots and entering the era of true digital autonomy. Look at standard workflows. They're reactive, right? You ask a bot a question, it fetches a policy document, it spits out an answer. But agentic AI, it is proactive. It's autonomous. You give an AI agent a broad goal like onboard our new intern starting on Monday. And the AI independently creates a multi-step plan. It logs into your systems, creates the IT ticket for a laptop, and schedules all the welcome meetings on your calendar, literally executing the whole process without you holding its hand. This leap from simple chat to autonomous agentic systems is fueling a massive economic boom. $267 billion. Let that sink in for a second. That is the staggering projected value of the global AI market by 2027. We are in the middle of a monumental, fundamental shift in how businesses operate and scale worldwide. And when you actually look at the timeline, the acceleration is wild. We started back in the 1950s with early rule-based programs. It took decades to get to the 2010s for the deep learning boom. Then, bam, just a few years later in the 2020s, the generative AI era exploded. The gap between these massive milestones is shrinking drastically. In fact, researchers are now pointing to the impending arrival of artificial general intelligence, AGI, within the next 10 years. Which leaves us with a pretty provocative question. When AGI finally does arrive, and it matches or even surpasses human thinking capacity, how are you going to adapt your skills to thrive? The future is going to belong to the people who understand these tools right now, inside and out. So keep experimenting, keep pushing the boundaries, and we'll catch you next time on The Explainer.